Assalamualaikum. Myself, Dr. Ansari Farzana W from Chemistry Department, J.A.T Art Science and Commerce College, Malegaon. As we have discussed in the previous section about the ionic equilibrium, strong electrolyte, weak electrolyte, moderate electrolyte, and the different factors which are affecting on the degree of dissociation, such as nature of the electrolyte, nature of the solvent, concentration of the electrolyte, temperature, and the presence of common ion. We will discuss here the same chapter, ionic equilibria. Our point of discussion of the today lecture is ionization constant of weak acid. Consider an ionization of weak acid. Weak acid is supposed to be Ha. In aqueous solution, the equilibrium is represented as Ha plus water. It gives us H3O plus A minus. Applying the equilibrium to the above equation, we get the equilibrium constant, which is given by the expression K is equal to concentration, ब्रैकेट जो चौकोन रहता है उसे concentration पढ़ते हैं. तो concentration of H3O plus into concentration of A minus divided by concentration of HA into concentration of H2O. In the equation, square bracket represents the molar concentration of the each species. In dilute solution, water is placed in a large excess. Its concentration may be taken as constant, and this constant is denoted as K. And the concentration of hydronium ion is equal to the concentration of H plus ion. Therefore, the above equation 3.2 can be simplified as K is equal to concentration of H plus. हाइड्रोनियम आयन की जगह क्या रखेंगे हम? H plus ion. H plus ion into concentration of A minus divided by concentration of HA into K. Concentration of HA into K. Taking the K from this right hand side to left hand side, so this equation becomes K into K dash is equal to H plus ion into A minus ion divided by HA. K into K dash, since the product of these two constants is equal to another constant, and this is called as capital K, or you can say that Ka, where K is the ionization constant of weak acid, and the equation 3.3 simplified as Ka is equal to concentration of H plus ion into concentration of A minus ion divided by HA. Hence, the ionization constant of weak acid is the characteristic constant and is equal to the product of molar concentration of hydrogen ion and anion divided by molar concentration of unionized acid. Ionization constant varies only with temperature, ionic equilibrium reaction. The ionization constant Ka of weak acid is also related to degree of ionization and initial molar concentration of weak acid. Ionization constant of the weak base. Consider the ionization constant of weak base. That means consider our weak base here is BOH. BOH dissociated into B plus and OH minus ion. Applying the equilibrium law of equilibrium to the equation BOH to B plus and OH minus ion, this equation can be written as Kb is equal to, Kb is a dissociation constant of weak base is equal to product of concentration of B plus and OH minus ion divided by concentration of BOH. In the equation in the above equation, the square bracket represents the molar concentration of each species, where K is the ionization constant of Kb is the ionization constant of weak bases. The ionization constant of weak base is the characteristic constant, and it is equal to product of molar concentration of cation and hydroxyl ion divided by the molar concentration of unionized or undissociated base. The ionization constant varies only with temperature and ionic equilibrium, temperature of ionic equilibrium reaction. The ionization constant of weak base is also related to degree of ionization and initial molar concentration of weak bases. Now, what is meant by pH scale? The pH scale was introduced by S.P. Sorensen in 1909. The pH scale measures the acidic or basic nature of the substances in aqueous solution. As we know that pure water is neutral. When we dissolve the chemical substance in water, the solution becomes either acidic or basic. The Sorensen defined the pH of the solution is negative logarithm to the base 10 of the molar concentration of hydrogen ion present in the solution. Mathematically, pH is equal to minus log of concentration of H plus ion. Therefore, pH is used to indicate the hydrogen ion concentration. The pH of 1 molar solution of strong acid is 0. Since the hydrogen ion concentration is equal to 1 mole per liter, whereas 1 molar concentration of strong base or hydroxyl ion concentration is equal to 1 mole per liter. Therefore, the hydrogen concentration will be equal to 1 into 10 raised to minus 14. 1 into 10 raised to minus 14 mole per liter as per ionic product of water. The pH of 1 molar NaOH will be 14. Therefore, the pH scale ranges from 0 to 14. A neutral solution, a pH less than 7 is acidic solution, and pH greater than 7 are basic solution, and similarly POH solution is also used to indicate the hydroxyl ion concentration. It is defined as the negative logarithm to the base 10 of the molar concentration of hydroxyl ion present in the solution. Mathematically, pOH is equal to minus log of concentration of OH minus ion. यानी pH 7 रहेगा तो वो न्यूट्रल कहलाएगा. एक स्केल लेंगे हम 1 to 14 लिखेंगे. 7 जो रहेगा वो न्यूट्रल रहेगा, लेस देन 7 एसिडिक, मोर देन 7 बेसिक, and this scale is called as BA pH scale. Thank you for watching.